I need a flat architecture and yeah, it's triggering the gene API and then doing all of that. Do that for you.
Sooner we can move our hybrid
Testing, testing, 1, 2, 3. Good. Welcome everybody to a rather impromptu meetup. We weren't going to have one in December because it's party season, and we didn't think anybody would come after last time. We decided to do one hour because Christopher Shadow is with us from Facebook, from Menlo Park, all the way from sunny California. Are you in London for a month? Okay, cool. So we spent about 6 hours one day last week just geeking out over beers, so God knows what time, which is a lot of fun. So he's going to be talking to us about React, past, present, and future. And I'm going to start. We decided to kind of restrict the numbers a little bit because we thought, like last time, it was like all the way upstairs and it was just ridiculous. We are going to get a new venue for January meetup, but we haven't had a chance to do it for this one because it's impromptu anyway. And because Christopher was here, we thought it would be at the street, so we decided to restrict numbers. So, which is probably a good thing actually. So, anyway, enjoy. And apologies for people at home watching that not being in person. So, do you want me to go first? Do you want to go first?
Yeah, sure.
Okay. So I was just going to spend a few minutes. I did put some slides together, but I haven't really prepared a talk in my usual style. But I just wanted to talk about a little bit about what we're doing. Actually, I better find the slides. I should have done this beforehand. What do I need to do?
Handouts as well.
How do I do that?
Just go to handouts.
I put a tab up for these two. It's like the third tab from the left.
And what do I need? Have we got feedback? Video? No.
Screen share the whole screen like that you will be showing people.
Entire screen, that one. Cool. Your screen sharing. So, like, I don't know. For me, one of the most interesting things about React is that isomorphic capabilities and the ability to render on the server and on the client, to start on the server wherever you are in your application and carry on client side as long as you like. We've been doing this for like about 11 months. We've tried lots of different things. I used to be really against single page applications because I thought they broke the web, and I think they used to break the web quite badly. But I think done properly, they can work with the web and get quite good results. And the important thing for me is, like, if you turn JavaScript off, can it still work all the way through? And if it can, and everything works just exactly as it would do normally, then that's good. We're onto a winner. So I wanted to talk a bit about some of the different things that we've been doing over the last 11 months or so. And the best thing about it is using cursors over immutable data actually just makes the whole thing quite magical and is actually quite fun. So what is isomorphism? Stuff that runs on the client server. So I think it's a misappropriated word. I don't think that Oxford English Dictionary mentions anything about clients or servers for isomorphism, but it's a word that we've appropriated for this sort of thing. And in the sense of single page applications, it's mostly just components and routes. And I think the routes is overrated. I think everybody tries to think, well, we only want to declare our routes once, because the routes are the same on the server and the same on the client, so we only want to declare them once. But when you actually dig into it, what routing means on the client is very different to what it means on the server. So on the server, routing means all sorts of different things. You've got HTTP to deal with for start off. So you've got gets, puts, posts, deletes, you've got headers, and you've got a form of response. And you've got all sorts of stuff that's only server specific. And on the clients, it's really just a state change through the URL. So it's a completely different concept. And so what we've found is that the routing side of it doesn't really need to be as isomorphic as we think it does. So we've got something where we do only declare our routes once, but it's really the components, it's really the application itself that is isomorphic. So get fast first page load and good for SEO, and in non-JavaScript environments it just works, which is great. So all those benefits we can get just by doing it properly, and I don't know what properly means. And there's lots and lots of frameworks and stuff that are coming out. There's lots of routing frameworks, there's lots of cursor frameworks, there's lots of all sorts of different things. These are just a few. React Router, which is sort of based on the Ember router originally, and React Router component, very similar. Mono Router, which is quite interesting, which we're using on an application at the moment, which we'll look at in a bit more detail. It's a little bit more how I expect a router to be, i.e. not really a component or part of the component hierarchy, but sort of like a cross-cutting concern that sort of slots across your application rather than in it. And we're also working on a sort of little bit of a framework at the moment, which uses page.js, which is like TJ's sort of cut down express router, and it uses that on the client and the server, which is quite interesting. So anyway, come on to that. But ultimately, it's all about the URL, right? It's all about state change through the URL, and that's really important, because when you press Command R or F5 or whatever to refresh, you need that same state back again. And immutable data, I think, is a massive part of this. I know that it's not really to do with isomorphic, but it's fantastic for building React applications. So what is it? Persistent data structures, where basically previous versions of the data structure are kept. So you always get returned a new data structure if anything's changed. So here, E has been added to F. And so all the way up the tree, G is a new reference, F becomes a new reference, E is added, D becomes a new reference because it's in the hierarchy, but B is still pointed to the original reference. And that's vitally important because in order to see what's changed, you can just compare references. So these two have changed, so notice something underneath it's changed. B hasn't changed, so we don't actually need to worry about anything underneath that. Sorry? Well, yes. I guess what I meant by deep is that anywhere in the hierarchy you can do an equality check. Yes, I suppose you don't need to go deeper than.
Not really shallow at all, is it? You just check the reference.
You just check the reference, exactly. Yeah. So we'll look at that in a second. So most immutable data is based around these hash array map trees, which I've lost a diagram from here. That's a real shame. Oh well, maybe it's not. They're like a hierarchical linked list, and really easy to use. You don't have to even think about how it's constructed under the covers. But it shares nodes all the way through. So in that diagram here, this is exactly what happens, and the nodes get shared, and you don't have anywhere near as much garbage collection as you would expect to have if you've got a complete new copy of the object every time. And one of the best talks, I think, on this is David Nolan, who wrote OM and ported Clojure to ClojureScript. This talk is well worth watching, and he talks all about how persistent vector actually works under the covers, and how all these pointers, so this is like an array, this is your actual data here, and there are pointers all the way through to it, so if you change one of these, you just change the pointers and everything works really well. I mean, it's like madly clever, but really, really good to watch that. So how about in React, and how do we use this in React? So early on, React added in the add-ons, there was the immutability helpers, which gives you sort of like a Mongo syntax, Mongo type update syntax that you can specify how you want to update your data. Really good. I think we can do better than that. So Closure and ClojureScript has immutable data structures by default, and it does all that structural sharing. And David Nolan took all the structures, the data structures out of ClojureScript, ported them to JavaScript to create Mori, but still quite potentially difficult to use. I don't know, for JavaScript people that are used to a little bit more OOE type thing and less functional, it's a bit weird, I guess, but I mean, it's lovely, but there's lots of helpers and stuff in there, which is great. And then Facebook, see, the things, tying these things together, brought immutable.js out a few months ago, and absolutely stunning. It was amazing to use. And then a few people have started building cursors over immutable.js to make it easier to store state in your application and to scope that state for your child components. So what we're doing at the moment is just having one data structure for everything. So just like in a normal application, all the application state, and I mean all of it, not every single last bit of application state, in one big data structure. And it's an immutable data structure that you'll get a different reference. You get a different root reference every time anything underneath it changes, and every node will get a different reference if anything underneath it has changed. And I wanted to just compare that with Flux, because we've talked about Flux in previous meetups quite a lot. And Flux sort of gives you this sort of like cyclic flow of data around your application through the views and through interactions and through dispatcher messages and into stores and back through the render cycle. And you can do exactly the same thing with a single data structure. So it's quite a similar pattern in a lot of respects. But we want to scope this single data structure for all our components, and we want all the components to allow them to update the data itself. So in Flux, they would dispatch a message, and the store would update the data. But kind of nice if you want a truly modular system to have components that are quite self-contained, that only see the data that they need to see and can only update the data that they need to update, and they can update it directly, and everything just sort of like hands off that. So in my head, that gives us a little bit more, you know, the components are much more self-contained, which is quite a nice thing. So cursors, that's where cursors come in. So I don't know if anyone's as old as I am in this room. I did actually use a fountain pen when I was at school, but I also used one of these things, a Cybral, and anyone who hasn't seen one before because they're a little bit weird, instrument of torture or something. The middle bit slides it around, and then you line up the cursor in the middle to read the values off, and you can do all sorts of approximate mathematics using it, so you can quite easily work out roughly what the answer should be. You know, you can do complex logarithmic stuff and all sorts of things. But the cursor is effectively like a window on this. So you move the cursor around, and it's just so when we talk about cursors, we're talking about it in this sense, not as in the little mouse pointer on your screen. So they're like windows into an immutable data structure, and they allow us to hold a reference. And the problem with immutable data structures is the references are changing underneath you, so you can't actually hold on to them. There's nothing to pass around. Whereas if you've got a cursor, it's just like looking at this, like one bit of that data structure, and you can pass that around, and it'll always look at that little bit, and just allow us to scope the data for the child components. And from a cursor you can get a subcursor, and from that you can get another subcursor, so you can carry on getting subcursors and pass them to child components in your hierarchy. We thought it'd be quite nice to have change handlers that fire on all the ancestors. A lot of cursor implementations have just a change handler at the root. You need one at the root because that's the one that's going to trigger the re-render, the React re-render, which is the single most important one. But it's quite nice if like a piece of data changes, but any cursors that anyone's got a reference to in the point to data above you also fire, which can be useful. So what cursor implementations are? Well, there's a few that are based on immutable JS and a few others as well. Immutable JS has its own cursor implementation, which used to be part of core, and it's been moved into contrib directory because it's like a separate concern. But it's a great cursor, and it's actually works brilliantly well, and it's got I think it has a single handler at the top, doesn't it? I think it does. There's also React cursor, which is based on the React immutability helpers we were talking about earlier. It's a bit older, I think. And then where are they used? Well, there's a React cursor mixin, which is like a component should update type mixin. And then there's Imstruct and Omniscient. Often Omniscient actually is quite interesting. So Omniscient uses Imstruct, and Imstruct uses immutable JS. And Imstruct is sort of like is a modified cursor, immutable JS cursor. So we put all this stuff together and came up with this. It's a bit mad, but we thought this would be quite a good pattern for a truly awesome isomorphic application, and we've started building applications using this sort of pattern, which is a little bit more complex than Flux, but in some ways it's easy. So if you follow the red line, which is the first page load, so if you type a URL into your browser, we've got an isomorphic router here which works on the client and the server. So it's the same code, it's the routes are declared once. We'll look at it in a second. But on your first page load, the server side implementation of the router renders the page. It may get some data from some services server side. It actually gets a cursor over your whole data set. So because it's your first page load, you need all the data. You need that one whole hierarchy. So the services can get all that for you and provide you with a cursor over that. We throw that cursor away. It's actually not used on the server. It's just there because the interface has to be the same as isomorphic. But anyway, we embed the data that's underneath the cursor into the page and return it to the user and render that. And then when React takes over on the client, it rehydrates that data back, creates another cursor over that, feeds it into the so it's the orange line we should be reading, sorry, first page load and refresh. So we create a cursor on the client and pass that into the React components client side. And that's exactly the same data that it had on the server. And because it's exactly the same, it renders exactly the same hierarchy with exactly the same checksum, and everything's good. And then if you've got JavaScript enabled, you're going around the green arrows then. So some interaction, the URL changes, you click a link or something like that, effectively, and the browser hijacks that link and calls some client-side services, which get some JSON data from somewhere, and then that updates the cursor using a path into the cursor that's derived from the URL, and so we can inject the data that we get back, or we can update effectively, because on the client side, once we've got our first cursor, we keep that reference forever. We hold on to that reference, and then we just update the data through the cursor, and then that will trigger any change handlers. The top one will cause the re-render, and we go around in that circle. So this is kind of like that green circle. That's kind of like the flux circle in this concept. The interface between the router and the service is the same here and here. It has to be because it's the same code. And then, but this is only gets, and here we're just doing state changes, right? So we can't do puts, posts, deletes, can't do anything fancy because such concepts don't exist on the client and it's isomorphic. So just a regular express router that's further up the stack, because once you've got going client side, you're going to be calling the JSON router for most of the time. You're going to be doing your puts, posts, deletes, whatever. Form posts could come here and they do a PRG, a post redirect get, and that kind of forces you into that pattern, which is great. But the important thing is that this is just data that comes out of that, and this is just HTML that comes out of this server side. And then if you've got JavaScript disabled, it just carries on going around that whole loop because we've got no client-side cursors. We've got a server-side cursor, we can do what we like on the server. We've got nothing on the client, so we just effectively just have to render that view and keep going around that loop. So, have I gone over time yet? Got a minute or two, haven't I? Can I just show you some code? So, or at least I could if I could find it. So, the router is actually really, really thin. There's nothing to it. And this is what I was saying about like it's a great idea to have your routes just declared once, but you're not going to do anything right because you're just going to hand off to these services, and these services are server side or client side, and they're not isomorphic, and they shouldn't be isomorphic. You don't want to share the server side code with the client really. And so all we're doing in the router is asking the service. Excuse me. All we're doing in the router is asking the service to get us a cursor over. If it's server side, it's over the whole data set. If it's client side, it's just over the bit we're interested in. And then we're just going to render a component and pass that back to the if you're server side to the client, or if the client side is just going to get rendered into the document, and that's it. And then we've got some server and client side services which are different, but the component hierarchy is this is just like a little noddy demo application, but it's just renders some components which passes cursors into or subcursors into it. So this is the root, kind of the root component. So this .props.state is a cursor over the whole data structure, and we can get like content.search.products or status or whatever, promotions, whatever it is. We can just get subcursors from that and pass those into the child components. And then in the child components where actually something happens, so if there's a form or something like that, that just has an action, and we literally just the router hijacks that and then navigates to a URL, and then the router will just fetch the Ajaxes for that URL from the server, and then update the cursor based on the URL. So putting that all together, it looks a bit like where is it? That. So if I refresh that page, the only components that rendered here were search and search results, and if I type something in here, then just the search box is updating. So that's no other components are updating at all. If I press enter, we do an Ajax, or the router does an Ajax call for us on our behalf, injects back into the cursor, and only the search results are updating here. And And then if I type something, only the search results don't re-render, just the search. So in the bottom left-hand corner, you can just see the components are updating, and nothing else updates apart from the components that actually have data that changes in them. I'm very conscious of going over time, so I'm going to wrap up. That's a quick word on testing. So if the render function is pure, it's actually quite easy to test. If you always give it A, you always get B. If you always give it A prime, you always get B prime. There's no side effects anywhere. So and it's repeatable effectively for any given input. And because the components are isomorphic, the test should be too. So we should run them on the server, and we should run them in a browser as well. So what we did was we just tried a few different things. We tried Jest, but we didn't like the auto-mocking side of it really, and it was just slow and cumbersome to use, but also quite difficult to. You find yourself turning auto-mocking off all the time just so you can get things in. And Jasmine React, which it hasn't had much love, but we're trying to give it a bit. But it's tiny. It's only this much code, but it's effective. What we effectively do in our tests is we like monkey patch Jasmine React a little bit, so that when it's in the browser, it renders into a component. When it's on the server, it renders to a string, and then we just effectively wrap either the inner HTML of the component of the stuff that's rendered into the browser or the string, wrap it with Cheerio, and then we can then just drill into the returned HTML just to see whether it generated the bits we're interested in. And just use regular Jasmine mocking or whatever it is we want to do to mock out the child components manually rather than do auto mocking. That's it. We're working on a model application called Reflex. Don't anyone nick the name, or we should prefer it set. Which is actually slightly different to what I've explained here, but we're trying to meld a whole bunch of different ideas, play with a few different things. So we've recently just built Fortnum & Mason Food Awards 2015 on using Reflex, which will be open sourced in the new year, but isn't done yet. What I've explained is something slightly different, but we just want to bring those ideas together a bit before we open source it, and we're hiring, and come join us if you want, and that's it. Cool, done. Okay, Christopher, it's all yours. You can take questions while I'm sitting. Yeah, does anyone have any questions?
Can you just put something on Slack saying I need to mention to you that Tesco.
Okay.
What you say is you think it's quite preferable to not have the same router on the server and the client because you want to deliver HTML on the server and JSON file on the client.
Yeah.
Can you say something about why do you think that's preferable? Why do you?
I don't think there's much point in isomorphic routing, but
Yeah. Well, compared to say returning JSON on the server as well and using React to render on the server in the same way as you do on the client.
so we are doing that. We are using React on the server. So that isomorphic router for rendering React components is exactly the same. That renders exactly the same hierarchy on the server as it does on the client. Exactly the same, except with the cursor and exactly the same data set. And then we transfer that data to rehydrating it. That's the React side of it dealt with the most. But then there's just lots of other things as well, like just data that you want that really isn't able to do with React.
Okay, so you do the same, you do more on the server.
More on the server, yeah. Yeah, it's the whole thing about like declaring new routes once and just, I don't know. I mean,
you can't really define them once because you need to expose your API endpoints to the client as well.
Yeah, exactly. So every route has got both like a client endpoint and this server. But you don't want me.
No, sure. It does answer my question, I guess. After, I guess we were thinking a little bit differently about it, but it's interesting to see.
I can share it. We will be sharing it.
So I had a question around whether you're using the kind of optimistic rendering and going back to any previous states. I'm trying to kind of figure out a clear way of describing this. So if you imagine you've got like 2 different pages with, say, 100 different results on either one of them, from what I understand of your demo, or from what you were talking through, you would effectively throw that data away as you update the tree, and that would get garbage collected.
So the reference to the immutable data structure is held on the client, and so that data can be held or thrown away depending on what the use case is. So if we make another Ajax call and it returns exactly the same results and it updates the cursor and that results in no change, then nothing will get re-rendered. Or if we just want to update the results so it's something different, then it would get re-rendered. But if we want to actually splat that before we start and then
so in your history, do you keep that old kind of reference? So in the off chance that someone goes back or reuses that same result?
So it's, oh, I see what you're saying. Right, so it's all in the URL, so we would make another Ajax request under the covers. So if you use your back button,
hang on. So I suppose to give a real example, so we actually tried to go down the isomorphic route, and in the end we had to come up with a bespoke data structure that would superficially look like it had cached the entire, well, in our case it's like hundreds and hundreds of JavaScript rows.
Yeah.
So we just strip everything but the top 25 because there's no browser window that could be long enough for that, and then we backfill the rest of them when the request comes back.
Right.
And obviously the really nice thing with React is it knows whether those elements have changed anywhere in there.
Exactly.
So it feels like a native app, like we want to shop it.
Yeah.
So I click there and it's like, well, why is it instant?
Exactly. So what we're doing at the moment is when you use the back button, we go and fetch the states in the URL, we'll go and fetch the data for the new state, update the cursor. If that results in no change, then React won't know. But anyway, even if it did, React won't do anything, and it's kind of like moving, they're not doing anything further actually. But it's nice to get that data again, just because it might change, and if it has, then you'll probably do one number.
Does your cursors also help you in not making unnecessary index calls? Because sometimes the data, maybe you already know the data hasn't changed. And yeah, I mean, I get that even if you fetch it again, a React will not re-render it unnecessarily. But I think sometimes you don't even want to fetch it if it's possible. Do you have something to check it? Do you really need to do another fetch?
Well, it's a multi-user app. I mean, there are some things that you need to ask the server for.
I'll make another example, like the search that you were showing before. Of course, you need to reload. You trigger the router, and you need to reload some part of the application. So you have a header, which some, I don't know, shared model that you only fetch once. You don't want to refetch like the project name or the client name or the user name.
Sure, yeah. So at the moment, what we've done will refetch it, but you could easily stop it from doing that if you don't want to. But the sort of data you're talking about that doesn't really change is sort of like almost the surrounding part of the page, you know, the bits that you would only fetch if it was a brand new server render, or if it was your first time rendering it. So which would be in the page when you loaded it anyway. So you're not going to be. It's almost like the URL state is like the middle bit or the bit that's new.
It only controls like the center of the page, let's say.
Yeah, it could be like more than just a single page. But it's really sort of like the current action or instance.
Well, so my name is Christopher Schiller, and I'm also called Visual. So I'm working on the core React team at Facebook, and I'm super excited to be here. Like, this is insane. Like, we released it a year and a half ago, and we're like this is some small leap we've been working on, and I don't know what if it's going to take. And like looking at like 50 people here in London, like this is halfway through the world from California, like this is mind blowing. Anyway, and also like the initial reception of React was pretty bad, so I'm really glad that we managed to turn it around. So in this talk, I'm going to try to explain to you how React was born, the current state, and the future. So we probably don't need to go too long on what is React. So it's a JavaScript library for building user interfaces. So this is like a very long name for just web building UIs. So the way people and the way we've like sold React is this is the V in MVC, and it's not like completely true because like it bleeds a bit to the C and you do the M differently, but it's a way to tell the people that React is only one small part of the puzzle, and you need to like have many other things. And this is like the way we want to do open source at Facebook is we only open source the elements that we know are working well. And then the rest, if we don't know if it's working well or not, we're not going to open source it, we're not going to talk about it. And so you're not going to get like a complete framework from us, like from day one, because like we cannot provide this, but maybe one day. So where did React come from? Have anybody here seen or read the Da Vinci Code? Yeah, a few people. So the story is that Leonardo da Vinci has been tasked with a very important mission. He needs to protect the secret of the Holy Grail. And this is like very important, and if anybody like discovers it, like the world would be so different. And it turns out that with a lot of like ingenuity and good Photoshop filters, there's one person, Jordan Walk, who actually like found this Holy Grail, and this is React. And unfortunately, like this is not how it really happened. So the way it all started is back in 2009 at Facebook. We had a really big issue. We were doing like string concatenation, like from in PHP to build the UI. And unfortunately, like if you build like do string concatenations to build your UI, you're going to have XSS issues. Like you're going to have injections. Like people are going to be named slash script, script alert, something like this. And this is especially like bad for Facebook because if you are able to run any JavaScript code within the browser, you have access to the user session. And this means that basically you can do whatever you want with the account of the user. So this was very bad for us, and someone from the security team actually came up with XHP. So XHP is something crazy where you can write markup within PHP. And so the history is that it wasn't like to mix and match markup and logic. Like this was not at all that. It was to fix a security issue. But it turned out that actually this has some good properties because now you can display divs and inputs and spans and like those dumb components that already exist. But you can also create new components. And for example, like this FV friend add button, you can give it a UID, and what you get is like a fully featured component that all your engineers can just like put in the application and it works. And we've been using this at Facebook for many years, and it's been like a real pleasure to work with it. And the interesting aspect of this is the way data flows in your application. So it comes from the root where you have like your FB application component, and then this is going to create like other component, which is going to create other component, and the data flow from the top to the bottom. And it never goes back up. So if you get a reference to this object, you cannot ask it for anything. So, oops. So at this point, we had like two extremely valuable properties, which were reusable component and explicit data flow and ownership. And we've been doing this on a PHP site for like years, and like everybody loves it. But more and more we started writing JavaScript because we wanted to make our ad dynamics and everything. And like it really sucks to write JavaScript like without a framework, or even with the like framework that existed. Like this was not enjoyable, and people that converted from PHP to JavaScript like were really pissed and wanted to go back to PHP and XHP. So our first like big JavaScript ad that we tried was the ads creation flow. And so this is like a pretty complicated application where you can see like all those transitions. You can see when you type on something, like the right bar like changes and it all updates well. And the way we implemented this was using data binding. So all the elements that you can see on the screen, they were data bound like all over the place. And we also had the concept of components. And we managed to get pretty far with it and implement all of this, but we had one big issue, which was debugging. So debugging data binding is pretty hard, because when you have a repro from a user, then you have no idea what actions led to the crash or the bug. And like we were actually like hitting a block, a big roadblock. We couldn't add more people to the team because they couldn't understand the code base, and they couldn't like every time they changed something, like they basically introduced a bug. And also it was pretty slow because of all the data binding. So we got one big lesson, which is like reusable component actually worked. So we had like this PHP XML thing with components was working, but data binding like wasn't working, and we didn't get the data flow right. And so this is where like Jordan came, and he figured out how to get the data flow right. And so this was also not like something that came out of a hat. He's been working on framework like for, I don't know, the past 10 years to build applications. And he's a big fan of crazy, obscure languages, like functional languages. And he implemented like, I don't know, 3 times a framework in SML. He implemented like many times in Axe. And when he joined Facebook, he continued like iterating on this framework using JS. And at some point, it actually picked up. And this is like where React started. And the reaction was pretty bad. So like his manager was telling him like, no, this is not going to work. Like stop like spending your time on this. Like we have like much higher impact things to do. But he kept doing it on the nights and weekends. And the way he set it up is, so his vision was, we're going to re-render everything every time. And like when you think about it, like this is crazy. This is never going to be performant. And so it's become like passionated with performance, and he implemented like the virtual DOM. He re-implemented like the event system and the diff algorithm, and actually it worked. And it was like super performant, and probably like this is why you're all here, because like it really worked. So he managed to find a team that was willing to use this like new framework, and like the team was like so impressed by it. It was like from the team that did that work on ads where like everything was data bound, like it was like so bad, and when they used the React, like they could add new people, like everybody got it like first try, and like sure there was a lot of like iteration during the process, but like it mostly worked. And so we decided to ship it, and it was, I don't know, 2.5 years ago. And like this was like a pretty big success for React. React was a pretty big success internally. So right now, basically, like the entire Facebook code base, like all the new products that are being worked on are using React. So we just hit the 10,000 React components in our code base. That's a lot of components. And so this is like Facebook centric, but a lot of companies outside of Facebook are also using React. So probably like if your company is not there, please send me an email or a tweet. I'll make sure you're in it. And like this is insane. But at the beginning, it was really hard for us to open source because we had to decouple React like from the actual Facebook code base. But the biggest issue was the code repository, because we're using like Git and Mercurial, and we have like a very different workflow for like doing code inside of Facebook than on GitHub. And then we had the issues of who is the source of truth between GitHub and Facebook. So the trade-off is if the source of truth is Facebook, then it's super easy for Facebook employees to like do changes and update it and make sure like it doesn't break Facebook or anything. But then if you're outside of Facebook, then you're a bit screwed because you have no idea what we're working on and you cannot like comment some diffs and things like this. But then if you're on the source of truth on GitHub, it's super easy to external people, but then the employees now, they have to learn how to submit pull requests to GitHub, how to test internally as well, etc. But we decided to be GitHub first. And what really pushed us is that we now have more than 50% of the commits that are from external people. So actually, like React is a real community project where like we got a lot of like really good pull requests. And so now all the code is going to GitHub first, like all the comments and all the commits and everything, even from the internal team is going to GitHub. And then once a week, we pull changes from GitHub to Facebook. So it was not an easy change, and we have to do like to add a lot of tooling, but I think it's like the best for React itself. So now this is like the state where we're in, and probably everyone asking here, where is React going? So we're not. So one thing to keep in mind is that we have 10,000 components. We have a giant code base of React. So anything that we're going to add, we're going to make sure that we first like need to like update all our code base like to the new version. So all the things that we're going to break or add or new features, etc., we're going to have like a migration path for you to follow. And we're also going to do it in like very conscious ways. So for example, if you try to update from 0.11 to 0.12, you see that we changed like a lot of internal things. And this decision was basically like 1 year in the making. And we've tried to only have one like big breaking change and make sure like that we can see like 1 year in advance so that we don't like re-break you like all the time. And we also like added a lot of documentation, make sure that we have a lot of warnings so that the migration path is easier for you guys. So now, what do we have next? So contrary to like most of the other like libraries or things like this, we don't want to add new features to React. Like we're going to basically keep React core as it is, and we're going to stabilize the API, like work out like the edge cases. And even more, we're going to reduce the API. We're going to remove stuff from React. And so this may seem crazy, but one good example is ES6 classes. So for example, in React, you have react.createClass. And what it does is a way to do classes. But it turns out that the new standard of JavaScript has a class syntax. So we want to, as much as possible, reuse the existing JavaScript library, like syntax, in order to first reduce the code size and complexity of the React internals, and we want to like be compatible as much as possible with other the JavaScript libraries and tooling, etc. So right now this doesn't quite work because ES6 classes do not have all the things that we currently support in React.createClass. but we are very fortunate because of the success of React to have 2 people in TC39, which is the standard committee for JavaScript. So we're actually like trying to improve the language, the JavaScript language itself, so that like the class syntax supports all our use cases and make sure like it goes into a good direction. So the other one aspect that we want to push, which is also which is very controversial, is CSS in JS. So I made a big talk about it, and you can see the slide online. But the idea that we have is we should split our apps by components. So the component should be like the unit in which you actually like compose your app. And one component, it doesn't make sense to have one component in 3 different languages. So we don't want HTML, JavaScript, CSS, and ideally, like we want to have all of the components of the way the component works into one single file. So this is like super controversial, but this is where we're going. And it turns out that we actually didn't need to like extend the React syntax or anything. This is actually working since we open source React. It's just a different way to code your application. But as usual with React, pretty much everything is optional. This means that if you don't want to use this, please don't use this. Please don't keep writing CSS. But if you want to write JavaScript, then we're going to make it easier and easier. The other part is web workers. So what do I mean by web worker? So with React, we're like super interested in performance and making like the most performant apps possible. And we sit at Facebook next to the people working on iOS and Android apps. And the way they extracted performance was to delegate all the expensive operations to a different thread. And so the idea is that the main thread only runs like animation, like 60 FPS smooth thing, but the bulk of the application is on a different thread. And so we're exploring doing that with React itself. So we would have like all the JavaScript for all the application in a web worker. And then all the diff updates, we just send them to the main thread. And then if you implement animations, then they're going to be butterly smooth, like basically by default. So this is work in progress. And then there's a big issue with React right now is animation and layout. Like, I don't think this is only with React, but this is like an unknown, this is a research project for like the web in general. We don't know how to do correct layout and animation the way native apps are doing it. And we have a lot of ideas into how to make it better, and we are exploring some other things. But what I really want to focus on to end this talk is that React is only the view, but in order to build an application nowadays, you need more than just the view component. So you need the M, which is the model. So you need to have like some way to like store your data. So you can use immutable data structure or anything, and you also need to get it from the server, and you need to synchronize it from the server, and you need to deal with optimistic updates, as it was told like in the previous talk. And like this part is big. On the C part, the controller, like you need to have like some kind of router. You want to do some isomorphic things, but those are only like 2 components of building web apps. I was talking that we're going to move more and more toward ES6 and ES7. How do you transpile those to real JavaScript that's going to be executed? Like you need to have all of this pipeline. Then you also need to add like a linting. You need to add, if you want to, you can have a type checking. You can have like so many other things, like CI integration and build tools and things like this. And right now, if you want to start an app with React, it's super hard to get everything set up, even if you've done JavaScript like for 10 years. And so we want to focus on those like probably the next 6 months or a year to make sure like you have a good first developer experience using React. So we're not going to write a framework because like it doesn't make sense to have like everything bundled, but we want to keep like many separated libraries that work well together and that you can just like replace if you want. So this is our like future vision with React. But what's really interesting with this is React itself is not going to change. Like we are really like happy with React, and don't expect any changes. Like you can rely on it, and it's only going to be faster, and the API is going to be like better. So thank you. If you have any questions. Yeah. Yeah. So this is a question that comes up like very often, and my best response for this is, what is Web Component trying to achieve? They're trying to achieve how do you organize your data flow, and how do you make things into components? And the answer is like, why don't you use React? So React is working today. We already know it's working for a lot of people. It's super performant, and I'm like, so what else does Web Component give you? And people like fall short of like answers for this question. So we really want to integrate with Web Components. So with the 0.12, we can actually do a react.dom .create element and put a Web Component in there. So if you want, you can use Web Components for React, and if you want, you can also write Web Component using React. But I don't think that our visions are really aligned in terms of like converging into like an actual implementation. So what we really want is to be interoperate well with Web Components, but we don't think like we're going to merge or anything. Yeah.
So in terms of like doing styling in JavaScript,
yeah,
browsers are currently optimized for the way CSS is used.
Yeah.
With classes and so on.
Hmm.
And you talked about doing inline styles and
Yeah.
So in pragmatic terms,
Yeah.
how is that working out in terms of how well it works with existing browsers?
Hmm.
How it works on mobile?
Yeah.
Also, within Facebook itself, presumably you have designers doing some of the CSS.
Yeah.
How are they getting on with it?
So inside of Facebook, our designers basically don't touch code. So like we work closely with them and they do mocks, but like they don't like touch the code. So this is for the engineer. So we don't have that much this issue. And then as for performance, so we're using it into a couple of projects. So it's still very early on, but performance has not been a bottleneck. And the crazy part about CSS, if you think about it, is for every node in your like for every DOM node, they have to check against the entire list of CSS rules that you have ever loaded in your page, which is a lot. And they have like many optimizations to make this fast, but like even like this complexity, like it's super crazy, and it doesn't like really show up in any benchmark. So if you use inline style, you're basically telling the browser, I want this element to have this style. So I don't see why it would be like much slower than.
Just kind of interested how well it would work out in practice.
Yeah. So in practice, like it works pretty well, and it hasn't been the bottleneck, so I haven't like actually tried to make it faster. But yeah, this is my. But I would love if you try it, and if you have like benchmark on your application, like please like reach out to me. Yeah.
But I can imagine that it works well in a lot of cases, but not everywhere. Like because you won't be able to abstract away and say like these two separate components share the CSS. You can't define everything in line. Do you still, even when you work with inline CSS like that, do you still have base CSS that you use as well, or do you? Yeah,
we still have the base CSS for like most of those things. And if you think about it, like if you want to share like some styles with many components, like this is just a JavaScript object. So you can create a new module that's going to share it, and you can create a function that returns like what you want. Like this is not like you have the full power of JavaScript to like modify those, and then you use inline style.
So you mentioned that you're looking to optimize this further with web workers.
Yeah.
How do you get over the tax on pretty much every browser but Chrome right now around transferring stuff between those two contexts? So I know there is this like transferable
Yeah.
kind of thing, but it's really limited about what you can actually send.
Yeah, you can only transfer like byte arrays, which is like pretty sucks.
Yeah, which
So-
is like typed byte arrays. And
Yeah.
so most stuff that you pull back from JSON just, well, it doesn't go over there with a lot of.
So one of the great things about React is the diff algorithm, like the output of a diff algorithm is actually like pretty small. So there's not a lot that you have to serialize. And
You have to serialize your entire, well, yeah, all those properties that you're sending over, or
no, so what you send from the main thread to React, you only send the events. So you send like this touchdown on this ID, and then from there you only send the diff. So create this element and insert it there.
So if this was a Flux app, then you would store your dispatcher.
Yeah, everything in the worker.
Stores, right? Okay. Can that request? That can do AJAX request.
Yeah, you can do AJAX from the worker.
Ah, okay. That would make sense.
And so right now the only difficulty with the web worker is you cannot implement a prevent default because the API is synchronous. So what we're trying is, which is like pretty complex to implement, but having some React components on the main thread that actually like run 60 FPS, and then some like the majority of your components in the web worker. So this is actually like a very active research area, but we think we can make it work.
Is any of that on GitHub?
Not yet. Right now it's only prototypes, and not even prototypes, like just ideas in our head. But we want like to push this. Yeah. So.
Yeah. Possibly a short question, which you might answer it instantly, and then a longer one if that's too quick. So I'm interested in what direction you're going, what thoughts you have about animations with React, because you mentioned you're looking at in the future. And also, are you extending React's API for the inline CSS?
Okay, so for animations, we have three main ideas. So the first one is declarative animation, where you have a component and you can say start animation and change like CSS transition, you can change like some properties. And then they implement it either in CSS or in a 60 FPS front loop that just does this. But this is problematic because you have no control and it's fire and forget, and like it's not a very good thing. The other thing that we have in mind is 60 FPS transition, where in the React component you call request animation frame, and you like update your state and the actual position of every element like on 60 FPS. And the last one, which is like pretty crazy, which is re-implement the Flexbox layout algorithm. And this is why, like, if you have inline style, then you can like feed it into the layout. And then, if you have this, then what you're going to be able to do is you do a layout, you do another layout, and you do a diff, and you see what are the width, height, top, and left that changed. And then you can declare transition for those. So what you can do is, for example, when something is inserted, I want all the top and left to move for 0.3 seconds linearly. And the issue with this technique is you need to re-implement the layout system because the browser doesn't give you hooks for this. For CSS transition, you can only do it for CSS properties, but you cannot do it for computed actual properties.
It'd be pretty useful for like resizing browsers and all sorts of other stuff that you have to do to jQuery.
And also, like, for example, if you have a grid of items, you want to use a display line block to position things, and when you want to remove one, you want to like smoothly animate. But with the browser, right now it's not possible. But if you re-implement the layout and be able to transition over like the top, left, width, height for this, it would be nice. So like those, the first two are like possible, and we're playing with it. The last one, I basically re-implemented Flexbox to try to make it work, and so far I have like some like good demos, but you need to have a lot of infrastructure and write your code in a certain way.
It sounds very cool.
Yeah.
It's in the moment using the CSS states on the React lifecycle API. is kind of okay for some stuff.
Yeah.
But it gets really complicated
Oh,
really
really?
quickly.
Yeah.
With like position absolutes and all sorts of things.
Yeah.
Yeah, that'd make a big difference. Keep working on it.
Cool.
It's very cool.
Any other question? Yeah.
You briefly mentioned about linting. What would
Yeah.
you recommend which approach to use, or what do you guys use?
So right now what we use is pretty shitty. So we transpile the code and then we use a GSLint. And we have some custom rules, but it's pretty shitty. And what I'm pushing forward is ESLint. So the really cool thing about ESLint is you write, it first generate the AST of your code, and then you write lint rules against this AST. And this is much easier than the other ones. Well, what are they doing is while they are parsing, they are like making like the rules. So instead of having to be a CS manager which has to know how to parse a tree, you can just use the tree and propose the tree and then have an intro. And Nicolas Zakas is working on getting JSX and ES6 support right now for ESLint. So it's work in progress. And yeah.
I was just wondering, having used React for how long, a very situation where you can think React isn't what you choose, where React kind of falls down.
So right now on Facebook, React, we shouldn't use React for anything that needs to be displayed instantly, because we don't have server-side rendering at Facebook right now. And so if you don't have server-side rendering, then loading all the JavaScript and loading all the data and then computing things, like this is like really bad. But other than that, like React has been, like it's basically a better DOM for us. And we've like strangely been super successful at all the things that we could throw at it. Like even, for example, charting, we wrote a charting library in React which outputs like to Canvas, SVG, and JML. So yeah, like if you have use cases where it doesn't work for you, please let me know. But yeah, I'm trying not to be bullshit, but yeah, like it's been working really well. You had a question? No? Yeah.
So you mentioned that you had a couple of folks on TC39 interested in the file syntax of what you need from it.
Yeah.
So what is missing from the ES6 classes at the moment that you're trying to get added?
Okay, so in React right now, every method is auto-bound. And this is like super important like for people because like this is super complicated. But in classes, it's not auto-bound. And so what we want to do is, we want to say, let's say this is get something, render something. So what we want to do is to say equals to like this. So this is an arrow function which binds correctly, and then this is an attribute. And so this is going to be a static attribute which has an auto-bound function. But right now you cannot even have attributes in your class. So like this is the main blocker. And then other like little thing that we have is, for example, if you have get initial state here, and you also have it in a mixin, what React is going to do is going to merge the two initial states. This way, like the mixin can define its own state. And if you just extend using a mixin here, you're not going to get this nice merging operation. So we're not really sure how to fix this, but yeah. And the other big thing that we're trying to push is immutable data structures, because this is so important to make React fast, and we want like browser support for them, because if they are inside of the VM, then they're able to do like a lot of optimizations behind the scenes that we cannot do ourselves. Yeah.
Yeah, you mentioned that you did do the server-side rendering of the sphere. So then with a React component, what do you send initially? No markup at all, so all the markup is everything.
Yeah.
And so
yeah, this is why we don't use React on newsfeed, for example. On newsfeed, this is still server-side rendered. But if you look at the command box at the top, then you have to click in order to display it. So we have the time to like prefetch it and this. Same for the chat, same for the buddy bar, same for the search. like all of the features that are not like directly in front of you on Facebook, we have to we can implement in React. So
So having spoken to one of your colleagues in the States a few months ago, who works in the Instagram team, because I know initially they did do the server-side rendering and then pulled it out. I think he was quite keen to reintroduce it on Instagram.
Yeah.
So
what happened on Instagram is they had a initial version of server-side rendering, and this is why there's server-side rendering like in React, like the React render component to string. But they initially wanted to do it for SEO, but it was too much a pain to maintain for little gain.
So the story that I heard was it was implemented by one guy, Django. And then no one wanted to support it.
Yeah, this is correct.
So they pulled it out. But from what I understand, it's coming back.
We are really experimenting with it, but maybe in another form and inside of the Facebook app. So Instagram was a brand new code base with 3 developers, so it's pretty small and it's it has no legacy, so you could re-implement everything in React. But within Facebook, we already have our own router. Everything is in PHP, so it takes time. But we definitely are interested in server-side rendering.
Is there a good reason why you haven't adopted template literal syntax for the JSX?
Yeah. So we thought about it a lot, but the syntax for template literal is super ugly. So so it would be like this, div, and then it will be something like this. And the tricky part is when you want to nest things, then you have to stop the JSX and then to restart it again inside, or you can make sure it's inline, but when you nest things, you've got to so you've got 2 solutions. One is to use JavaScript, but okay, let me phrase it. Okay, I don't have a good example, but when you nest things, the syntax becomes really bad, and we've got to basically re-implement a JavaScript parser inside of the XML language, inside of the XML language inside of the template literal. So it was a really heavy infrastructure, and this would be too slow to do at runtime. And so if we don't have to do it at runtime, then you've got to do it at compile time. But then if you already have a transform, then why wouldn't you use JSX? Because you already made that effort to have a build tool and everything. So
you're still losing the fact that if you write JavaScript, then you're writing the same language as millions of other people.
Well, yeah, but this was a trade-off, and in order to make sure that it didn't stop people, we made sure that you could use React without JSX. So we didn't want to invest a lot into a parser for something that we didn't like. So we provided something that we really like, and if you want to use it, or pure JS and. But yeah, the middle ground trade-off with template literal was not a good one, in our opinion. Yeah.
How many people are actually working on React in Facebook?
So on React Core, we have 3 people full-time, but on all the MC, all the other parts, the product infrastructure at Facebook must be 30 or 40 or something like this. And then there's all the product people using React. But yeah, the core of React, we are really few.
Only 3 people merging per request.
Yeah. And yeah, at this point, React is pretty stable. So we don't have there's not a lot of work to do inside of just React, which is good. And, Yep.
Do you have any examples of anti-patterns or things you've seen in the wild where people use React in a way that kind of wasn't the way it was supposed to be?
Yeah. Don't mutate your props. What else? Don't use refs. Don't use refs if you don't have to integrate with something else. Don't use get.node to do weird things. Don't What else? Yeah, all of those. But we actually try to make it obvious when you do things that is not intended. So, for example, like setting our HTML dangerous thing, like if we don't want it, if we don't want you to do it, then we're going to either put a warning or make the name like super bad or make it hard. The one thing that we didn't get right is mixins. So because we made mixins so powerful and so easy to use, people are actually using them. And this is very bad because this is like inheritance and you don't know, like, if you call a function, you don't know where, from which mixin it's inherited. And like, I wish that we didn't introduce mixins. So like, there are really good use cases for mixins, but there are very few of them.
Do you have ideas on how that will work? Is using, say, React with TypeScript or annoying things is when you've got mixins trying to represent that possible.
Yeah. So right now, Flow, I don't know about TypeScript, but Flow doesn't understand mixins. But we're working with them so that they can understand mixins, or maybe using going through ES6. And the way it would work is when you extend. When you extend, you can do extend mixin. Okay, it's so black. Mixin and here the mixin. And so maybe Flow will be able to like understand this. But yeah, this is like we have an issue with mixins and type checking as well. So yeah, mixin is bad. Like use composition, like create a new component to add new behavior instead of mixin if you can. Yeah.
Going back to the CSS stuff again. In that JSON implementation you had, do you know how responsive styles and media queries would fit into that?
Yeah. So I want to px or whatever. Yeah, so this is
that's the same as JavaScript.
Yeah, this is JavaScript.
For server-side rendering, how might that work?
Either you have to know from the user agent the size, but this is pretty shitty. So like use CSS. Like, like don't think like you should. Like this is one of the big things when we announce we're working on something is that people take it super literally and like lose any sense of like common sense. And when you say like using like JavaScript to write styles, but don't like if there are some cases where like it doesn't make sense, don't use it. And
it seems to me that it makes perfect sense for like structural styles, because a component would be really self-contained if it had enough style to make it look look right.
Yeah.
Sort of structurally on the page. Yeah. And then the theming styles can come in from CSS files.
We actually want one component to own its theme. I don't believe that you can have one HTML that can be styled in so many different ways with CSS. So this is like a common idea, but I've never seen it working. And I really like, for example, what you can do is to have a base React component that has no or barely any style, and then but has logic, and then you have like many components that use this base component for the logic, but then fill in style with prop types. And because style are just JavaScript objects, you can have a prop type, and you can use prop type shape to make sure that you only accept style that you want over hidden or whatever. Yeah.
But if you mix inline styles and proper CSS, you get specificity issues. Like how do you handle
importance?
Yeah.
Like
don't you run into massive headaches doing that? I mean, because important is
like important just overrides like
yeah, sure.
So important has been really banned because people like use it in very improper way. They use it to modify other styles on other style, and like you shouldn't do that. So, like, if you really want to override an inline style, use important. But then, like, what we've seen so far is that actually, like, inline styles like this are super powerful. And the way I tried it is, I was like, okay, I'm going to run into so many issues. This is never going to work. And actually I tried it, and I tried like to put like the most extreme things, and it just worked. Like you have JavaScript, you can do anything you want. And so I didn't run into like those issues yet. But yeah, import, like I had to use import like 1 or 2 times to override things, but yeah, most of the time I didn't. And I think we are out of questions. So thank you very much.
Thank you very much. You can have a next meeting on second, third week in January. Some pizza left and some beer, so help yourself. We'll talk about it. Thank you very much, Christopher.
I'm sure like if you have any questions.
Cool, thank you.
What's in here for? We are setting up